All right, hi guys. Today we're gonna do volumes of cones and volumes of pyramids. They're kind of related to prisms and cylinders that we did last week in that each of them is just 1/3 of, in this case, a cone is 1/3 of a cylinder and a pyramid is 1/3 of a prism. Okay, so the only thing that really changes when you're given a cone as to a cylinder is the volume, if you remember, of a cone is pi r squared h, because the base of a cone is a circle times the height. All you gotta do is throw a third in front of it and that's it. So if a cone and a cylinder have an equal radius and an equal height, they will be in a 1-to-3 ratio. So 3 cones of the same size could fill a cylinder of the same radius and height. Okay, so the first couple we're gonna do is just, this first one is just a straight find the volume. Okay, so you do have the radius, you do have the height. They're in the same unit, so it becomes just a straight plug-in, right? So we're gonna plug in the radius is 4, the height here is 8. Okay, it does say in this one, you're in terms of pi. So remember, in terms of pi means multiply everything out, leave off the pi, multiply everything out here, and you get 128/3, and then tack the pi back on. Okay, now the thing about this one right here is in this one we actually have we don't have the height of the cone. The height of the cone, remember, height is always a perpendicular thing, so this is actually the height of the cone here. Okay, what we have is in this case what we call the slant height of the cone. The slant height of the cone does not go into that formula. The h in the formula is the height of the cone. However, if you notice, because the height makes a right angle, the radius, the slant height, and the height of the cone all form a right triangle. So what we could do first is a little Pythagorean theorem to find the height of the cone, and the height you end up with just a whole number as 12. So once we have this 12, oh, and by the way, the units, okay? So still volume, so this is inches cubed. This one, the units here, you actually weren't given units in this one, so we're just gonna substitute in. And now we're gonna use that 12 there. So again, if we're keeping things in terms of pi, we're gonna multiply out just the numbers and we get 100. We're gonna tack that pi on. Since no units are given, I'll just write units to the 3rd power, okay? So again, 2 just kind of straightforward volume formulas, one where you just have to find the height of the cone first, okay? And then the next one I want to do is number 7. So number 7 is just one where you have to work a little backwards. You're given the volume of the cone is 27 centimeters cubed. You're given the radius and you're asked to find the height. So again, if we're using that formula, 1/3 pi r squared h, we know the volume is 27 pi. We know the radius is 3. We're just looking for the height. So we're just gonna have to solve this equation. Okay, so the one thing we could do here, so we have 27 pi. If we do this math, we get 3 pi h. And then we just have to divide away. So we know the pi's are gonna cancel when we divide. When we divide both sides by 3, we get h equals 9. And in this case, it would be 9 centimeters. Okay, it's just centimeters because it's just a height. Okay, number 10 is kind of similar to like those shaded area problems we did earlier in the unit, because all you're being asked to find is if you take the cone out of the cylinder, how much of the volume is remaining. Okay, so you could think of this as a shaded area problem. So you want to get rid of the cone out of this cylinder. So if we start with the volume of the cylinder, okay, so volume of a cylinder, remember, is pi r squared h. So it's the cone volume without the 1/3 in front. So just like before though, we have the height of the cone, right? Because the height of the cylinder over here of 15 inches would also be the height of the cone. We do have the slant height of the cone in here is 17, but what we don't have is the radius right there, okay? So again, we could do a little Pythagorean theorem here. So I have the radius squared plus plus 15 squared equals 17 squared, right? And then we'll end up getting the radius is 8. Okay, this is just another triple, 8, 15, 17. Okay, so once I get the radius is 8, I could plug that in to my cylinder formula. The height is 15, okay? And I would get the big volume here ends up being 960 pi, okay? Oops, sorry, that's not boxing it up, okay? So that's the volume of the whole cylinder. Now we can go two routes here. If we remember that a cone, if the cone and the radius have the same height, the cone and the cylinder have the same radius and the same height, which they do. The radius of the cylinder is the same radius of the cone, the height of the cylinder and the height of the cone are the same. Then this cone should represent 1/3 of the volume of the cylinder. So what you could do from here on out is you could just say, all right, 2/3 of the volume is remaining. So at this point you could just say, all right, well, if I take 2/3 of 960 pi, I'm gonna get 640 pi. You could go that route. But let's say you forget that they're going to be in this, that it's going to be a 1-to-3 ratio here. That's fine. What you could also do is find the volume of the cylinder that's on the inside, right? So if we do that, it's just 1/3 pi times the 8 squared times the 15, okay? And you'll get the volume of the cone to be 320 pi. So what you could do is kind of like we did with the shaded area, area of the outside minus area of what you don't want. We could do volume of the outside, which is 960 pi, minus volume of what we don't want, which is the cone, and get the 640 pi that way. But either way, right, we get the same answer. So it just depends on how you see it. Okay. Any other shaded volume formula where you don't know the ratio, that is what you're going to have to do. You're going to have to do the volume of the big thing minus the volume of what you do not want. Okay. Then similar to this, where we involve a cylinder and a cone, is number 12. Okay. Number 12 is this shape of this, like, I don't know, weird little peggy thing where we want the total volume. So instead of subtracting volumes here, we're going to add volumes, right? So we need the volume of the cone plus the volume of the cylinder to get the total volume. So the cone. So let's look at the cone. So we know the radius of the cone. If we do a little subtraction here, we're going to know the height of the cone is 6. So the volume of the cone is going to be 1/3, okay? And that is a 3 squared times 6, okay? Plus the volume of the cylinder. So remember, the volume of the cylinder is just going to be pi r squared, which is 3, times the height of the cylinder, which is 12, okay? So if you do the volume of the cylinder here, the cone here, you get 18 pi. The volume of the cylinder ends up being 108 pi. So we can add these because they're both pi's, and we get 126 pi. And again, that little symbol is feet. It's going to be feet cubed here as our units, okay? Again, it didn't say whether the volume should be in terms of pi or a decimal. We'll always just do it in terms of pi if they don't ask. It's just easier, it's less work to do, okay? All right, so then the next part of this is volumes of pyramids. So pyramids are kind of, so if like you think of a cone is a circle base that comes up to a point. Right? A pyramid is the same thing. A pyramid, you could have a different shape base, but if you bring it up to a point, it's still 1/3 of whatever volume of the base it was. So in other words, a square base in a full prism will be a cube, right? So a pyramid with a square base is just going to be 1/3 the volume of a cube. If the base is a rectangular prism, so remember rectangular prisms are length times width times height, it's just going to be 1/3 length times width times height. If it's a triangular base, again, you do the volume of the triangular prism like we did last week, but you multiply it by 1/3. So that's all it is, okay? So you just have to be aware of what shape base you have, okay? And then chuck a 1/3 in front. So if we look at on page 28, Page 28, we start with what we see here is a square pyramid, and they have to tell you, if they don't give you the picture, they have to tell you what the base is. So if it's a square base, we think of a square to a square is a cube, right? So last week we learned the volume of a cube, okay, is side cubed, right? So this is, oh, I'm sorry, this is not a cube because the height is 9. So we have just basically a rectangle base times the full height. So again, if this didn't come up to a point, if it just went from this square base up to this square with a height of 9, we would find the volume with length times width times height. Okay, what we're just going to do here is just throw a 1/3 in front, and we're going to do length times width times height. Okay, so just think of it as a square to a square that's connected by a height of 9. Okay, so it's not a cube because of that height of 9. Okay, if the height was also 6, then it would be a cube. And then you just do the math here and you get 108, and again, still centimeters cubed. Okay. Number 4 doesn't draw it for you, but it tells you your base is a rectangle, right? So again, a rectangle is length times width times height. So it's just going to be 1/3 length times width times height. But this time, do you see they give you the volume? So they give you the volume is 288. They give you the length is 8. The width is 6, and we're looking for the height. So it's just one where we have to go backwards, right? So here you can multiply this out if you want. You just get 16, divide by 16, and you get the height here is 18. So this would just be centimeters, right? Because it's just a height, it's not a volume. Okay, so that's it really for pyramids. Pyramids are really not that big of a deal, but it's just 1/3 whatever the volume would be if it had been a full prism. Okay? The last 3-dimensional object I want to talk about is a sphere, and this will be the last one for the unit. Okay, so a sphere obviously is a 3-dimensional circle. If you take a circle and spin it, you get yourself a sphere. Okay, so a sphere is just like a ball. So the volume of a sphere is 4/3 pi r cubed. Now, had you been taking the Regents, this is something the Regents gives you, okay? Sometimes they ask you for the volume of a full sphere. Sometimes they ask you for half a sphere. Half a sphere is called a hemisphere, which again, I'm sure you all know this already from earth science. But if they only ask you for the volume of a hemisphere, you're just gonna multiply this volume by a half. Okay, so the very first one we have, and again, the good thing about a sphere is you only need one dimension. You only need to know one thing, and that's the radius of the sphere. So this is a straight sphere problem. You're given the radius. You don't have to do anything fancy. You just plug it in here, and you get 972 when you do out the math. Keep on the pi because it did say, well, it didn't say in terms of pi, but we said if it doesn't say, just leave it in terms of pi. Okay, one less step to do, right? If it did say a decimal, again, you would just type the whole thing into your calculator and round it to whatever they want you to round to, okay? So the next one I'd like to do is number 2. Number 2 is that hemisphere. Do you see? We don't have a full sphere here, so this is gonna be 1/2 4/3 pi r cubed, okay? Or again, you could write this as 2/3 if you wanna actually multiply the 1/2 and the 4/3, it's 2/3 pi r cubed, okay? So when we plug this in, we do just given the straight radius here is 6. Again, if we're just gonna stick to in terms of pi, when you do the math here, you get 144. Tack on your pi, the units would be centimeters cubed, okay? The variation on it is the going backwards problem, like number 4, where you're given the volume. So again, you start with the formula. It did say it was a full sphere. So you have 500 pi over 3 equals 4/3 pi, and now you're looking for the radius, okay? So the first thing we're gonna have to do is isolate the radius. Now here's the thing, if you want, since you have pi's on both sides, you could just cross them out, divide both sides by pi's. Do you see both sides have over 3? Technically, you could cross them out. It's like timesing both sides of the equation by 3. So what you're left with is just 500 equals 4r cubed. If you divide 500 by 4, you get 125 equals r cubed. So now you just have to cube root both sides to get r. Now the cube root of 125 is 5. Remember, if you are using your calculator, the cube root button is math number 4, okay? Now, the last problem I want to do, number 7, is just one of those where they kind of like extend it. It says, Tamika has a hard rubber ball whose circumference is 13 inches, and she wants to box it up in a gift box, and she wants to know the smallest box she can buy. Fine, okay? So again, if you're putting, just imagine in, 2 dimensions, but if you are putting a sphere, okay, inside a box, right? It would really have to do with the radius or the diameter of the sphere. Technically, the diameter of the sphere. The diameter of the sphere would have to be smaller than the side of the box, okay? So again, this box really is a cube you're putting it in, but sometimes, again, drawing 3D pictures is not my thing, I can tell you that much. But if you just think about it even 2-dimensionally, you need the diameter of that sphere to be less than the side of the cube. Okay, so if we start with what we know, so let's think about it, the sphere as a cross section, right? So the cross section of a sphere, if you cut it, technically if you cut a sphere anywhere, you're gonna get any horizontal or any vertical cut, you are just gonna get a circle. So what I know about this circle is the circumference. Okay, so you can recall, if you don't recall and you have to look it up, that is fine. The circumference of a circle formula is 2 pi r, or pi times diameter. It doesn't really matter which one you use in this one, okay? So if we know the circumference of this little cube is 13, right? So I have 13 equals 2 pi times the radius, right? So if I divide by 2 pi, now remember, if you're dividing by more than one thing at once, I do want you to use the N/D button on your calculator, right? You get the radius, we'll just make it a decimal. As long as we go 1/10, we're fine. So the radius of this sphere would be 2.1, right? My concern is really the full diameter, right? So the full diameter of the sphere ends up being 4.2. Okay, so and they said the box could come in whole numbers, right? The box could either be 3, 4, 5, or 6. So the diameter is 4, which means I can't use a 4 size box. It won't fit because it's bigger than 4. So the smallest box would be one with 5 inches. So you have to round up no matter what. So even though that's only 0.2, we still have to round up to a box that's 5 inches to fit it. Okay, so that's really kind of the variation on that. So what that does is it does complete all of our shapes. We've done them all. We did all the prisms, cylinders, pyramids, cones, and spheres. So that represents all the different things volume-wise that we are going to do. Okay?